The universe is often described as vast, mysterious, and incomprehensible, yet no description can ever truly capture the scope of what it is. For centuries, humanity has gazed up at the night sky, wondering what lies beyond the stars and what forces shape the cosmos. The deeper we explore, the more astonishing and puzzling the universe becomes. In many ways, our discoveries raise even more questions than answers. From the earliest astronomers mapping constellations to modern scientists using space telescopes and particle accelerators, each step has revealed just how complex reality truly is. But what if the universe is not just vast but also stranger than we could ever imagine? One of the biggest breakthroughs in cosmology was the realization that the universe is not static but expanding. This concept, which today may sound simple, was revolutionary when first introduced. For centuries, people believed that the cosmos was eternal and unchanging. Then, in the early 20th century, astronomer Edwin Hubble made a groundbreaking observation. By studying the light from distant galaxies, he discovered that they were moving away from us, and the farther away a galaxy was, the faster it seemed to recede. This meant that space itself was stretching, carrying galaxies with it like raisins embedded in a rising loaf of bread. This discovery laid the foundation for the Big Bang theory, the idea that the universe began from a single, unimaginably dense point around 13.8 billion years ago and has been expanding ever since. The notion of an expanding universe was not easy to accept at first. Even Albert Einstein initially resisted the idea, preferring to believe in a steady, eternal cosmos. He introduced what he called the cosmological constant into his equations to counteract the effects of gravity and keep the universe static. However, after Hubble's observations, Einstein himself reportedly called the cosmological constant his greatest mistake. Yet, in a strange twist, modern discoveries would show that he may have been onto something after all. In the late 1990s, astronomers studying distant supernovae made a startling discovery. Instead of slowing down due to gravity, as everyone expected, the expansion of the universe was actually accelerating. It was as though some mysterious force was pushing galaxies apart with increasing speed. This invisible energy came to be known as dark energy. Though scientists could measure its effects, they had no idea what it was. To this day, dark energy remains one of the greatest enigmas in science, making up about 68% of the universe's total energy content. It acts like a cosmic repellent, stretching space itself at an ever-increasing pace. But dark energy is only part of the mystery. When astronomers measured the behavior of galaxies, they realized there was another invisible ingredient at play: dark matter. Galaxies spin so fast that, according to the laws of physics, they should be torn apart. Yet, they remain intact, as if held together by some hidden glue. This unseen mass does not emit or absorb light, making it completely invisible to telescopes, yet it exerts a powerful gravitational pull. Scientists call it dark matter, and it is believed to make up about 27% of the universe. Ordinary matter, the stars, planets, gas, dust, and everything we can see, accounts for less than 5%. That means most of the universe is made up of things we cannot see or directly detect. Imagine that. Everything familiar to us, from the atoms in our bodies to the galaxies we see in the night sky, is just a small fraction of reality. The rest is hidden, locked away in a form we can only sense indirectly. This realization challenges our understanding of existence itself. What is dark matter? What is dark energy? Are they related, or are they completely separate phenomena? Scientists around the world are trying to answer these questions with powerful experiments, such as particle colliders and deep space observatories. The discoveries of dark matter and dark energy also reshape how we think about the fate of the universe. If dark energy continues to accelerate expansion, then billions of years from now, galaxies will drift farther and farther apart. Eventually, distant galaxies will move so far away that their light will never reach us, making the universe appear emptier. Some theories suggest this could lead to a big freeze, where the cosmos becomes cold and dark. Others imagine even more dramatic endings, like the Big Rip, in which dark energy eventually tears galaxies, stars, and even atoms apart. At the same time, scientists consider the possibility that the universe's expansion could someday slow down and reverse, collapsing back in on itself in a big crunch. Or perhaps the universe cycles endlessly through phases of expansion and contraction. Each of these scenarios reminds us how fragile and temporary our moment in cosmic history truly is. What makes all of this even more fascinating is the possibility that our universe might not be the only one. Some theories suggest the existence of a multiverse, an infinite number of universes, each with its own laws of physics. If this idea is true, then our cosmos, vast as it seems, might just be one bubble in an endless cosmic ocean. Within these other universes, time, space, and matter might behave in ways we cannot even imagine. Another key to understanding the universe lies in cosmic background radiation. This faint glow of microwaves fills the cosmos, a remnant of the Big Bang itself. It acts like a photograph of the universe when it was only 380,000 years old. By studying this ancient light, scientists have pieced together clues about the early cosmos, including how galaxies formed and how matter clumped together. Every new measurement adds more detail to the story of our origins. Yet, the more we learn, the more humbling the universe becomes. Human beings live on a small planet orbiting an ordinary star in a galaxy among trillions. On cosmic scales, we are tiny, almost invisible. And yet, through curiosity and ingenuity, we have managed to unlock some of the deepest secrets of the universe. Telescopes orbiting above Earth's atmosphere can see galaxies billions of light-years away. Space probes have traveled beyond the edges of the solar system. Particle accelerators recreate conditions close to the birth of the universe. All of these efforts are pieces of a puzzle we are slowly assembling. It is awe-inspiring to think that, despite our smallness, we are capable of asking such profound questions. What is the universe made of? Where did it come from? What is its ultimate fate? These questions do not just belong to scientists but to everyone who has ever gazed up at the stars and wondered. Perhaps the greatest mystery of all is that the universe seems fine-tuned for life. If the laws of physics were even slightly different, stars might not form, galaxies might not exist, and planets like Earth might never have arisen. Why is the universe the way it is? Is it chance, necessity, or evidence of something deeper? Some suggest that in a multiverse, we happen to live in one of the rare universes where life is possible. Others believe that there may be a hidden principle or truth that ties everything together. As we continue to explore, new technologies promise even more astonishing discoveries. The James Webb Space Telescope, launched in recent years, has already provided glimpses of galaxies formed just a few 100 million years after the Big Bang. Future observatories may even detect the fingerprints of life on distant worlds. At the same time, underground detectors search for elusive dark matter particles, while scientists test bold new ideas that could redefine physics itself. The journey is far from over. In fact, it may have only just begun. Each answer uncovers deeper questions, each discovery reveals more layers of mystery. That is what makes the universe so endlessly captivating. It is not just a place filled with stars and galaxies but a story still unfolding, a story that we are only beginning to read. In the end, perhaps the universe is not meant to be fully understood but to be explored, questioned, and marveled at. Its vastness reminds us of our limits, but its mysteries invite us to push those limits further. Whether we are peering through a telescope, conducting an experiment, or simply looking up at the night sky, we are part of a grand human endeavor to seek knowledge in the face of the unknown. And maybe that is the true beauty of the universe, not that we will one day solve all its mysteries, but that it inspires us to keep searching, generation after generation. The cosmos is vast, ancient, and filled with wonders, and it will always remind us of one thing: that we are explorers at heart, destined to seek, to question, and to dream.